Hi guys, Prerit this side, and let me start the talk. Just give me a thumbs up in the chat if I'm audible and visible to you. Also, this talk will be a very much impromptu talk. Okay, so we will be talking in the YouTube chat, and I will be continuously monitoring the chat. So just keep me updated in the YouTube chat. Okay. So let me start. So the agenda of my talk is the coldest Monday with the $1 million in cloud bill, and how Terraform helped us in rescuing this particular thing. Okay. So first thing, who am I? I'm Prerit Munjal. I'm founder of KubeCloud. KubeCloud is a unified platform for cloud and DevOps professionals, students of any level. Okay, so we are still building, and it's just been 1 month that I'm building this company. So if you want to check it out, the platform is under maintenance. Okay, so you won't be able to see anything. Now, I've also worked at Viz Labs. So this case study is particularly when I was working at Viz Labs. How, because this is a very classic case study, and I bet that nobody of you would ever thought of applying IAC to security. Okay, so it is going to be a very good talk and a very different talk than other IAC talks. Okay, and these are my socials: LinkedIn, Prerit Ivan Minjal, and on YouTube, I have a YouTube channel as well. So with the name of Tech with Prerit, and on X, I'm Prerit_Munjal. Apart from this, I'm a part-time certificate collector, so I have bunch of certifications other than HashiCorp ones because nobody gave me the vouchers. And next thing is I am an international speaker, so I give talks at CNCF events, DevFest, and a lot of other technical events. Okay, so what's the agenda for today? First thing is, what's this $1 million bill? Okay, and how in the world we were billed $1 million. And second would be, we will be discussing the root cause. Third will be, I will be telling you what were the hot patches that we applied. Okay, total architecture in depth review. And fourth will be, I will be talking about something known as quotas and metrics in Google Cloud. And in the last, I will tell you how IAC helped us. Okay, so just stay with me throughout the event. uh, so this was our architecture. Okay, obviously it is not that good architecture, or that elaborated architecture, because uh, uh, as I left the company, so I couldn't share all the necessary knowledge with you. But this is how our architecture looked like. As soon as a guy logged in into our, or just came to our platform, first tell me let me tell you about Viz Labs. So Viz Labs was not an end user company. Okay, so we built something on top of Google Cloud, AWS, and Azure, and sold it to the customers. Okay, so it is an edtech platform where you can just come and play around with labs, or play around with anything in general with tech. So as soon as the user came into our platform and started one of our Google Cloud labs. So to be specific, this talk will be primarily based on Google Cloud and its security. So as soon as the user clocked in any lab, then this was the first step, that a G Suite ID would be created. So if you have tried any of the labs, so they give you generally an email ID with their domain name. So first step was the creation of the email ID with that domain name. Second would be, some Google Cloud magic would happen. Okay, so I can't reveal those, but we had a very strict policies. We had very much shell scripts into play that were doing their part, and it would pick the projects, because every user was granted one project. Okay, as we know that in cloud there are multiple projects. We had 400 plus project, and our algorithm picked one of a project, and just gave it to the user. Okay, this was the simple architecture. Now let me go a little bit into depth about what is this architecture look like. Okay, so first thing was, we had around 25 plus services. Okay, The services involved data flow, BigQuery, Bigtable. Okay, so we had multiple services come into play, and one thing was that our architecture, as you saw, these 400 projects, these were just a playground. Okay, so we were not implementing any security policies, we were not implementing anything, we were just applying some IAM permissions and then assigning it to you, assigned it to the users. Okay, so there were no security concerns, or we never thought that this would happen. Okay, so it was just a plain playground, and we were running any services and just playing with the IAM part. Now what happened on and also talking about this architecture, I will discuss a little bit in depth after some moment. So after some time, what happened was some crypto mining attackers came. Okay, so it was in the month of May and June 2022. So this is a case study from very long back. So multiple crypto miner attackers came. So what they did was they did something that I will tell you in the later phase, and they tried crypto mining attacks. So how they did was they created some compute engine instances, and they took the RDP access and they did the stuff on that. Okay, and as I told you that we were not having that many security measures, so we were not even knowing that these guys were just mining the bitcoins. Okay, and this the entire attack was happening in during the weekends and during the night. Okay, so after 10 p.m. from till 3 a.m., all these things were happening, and it was on a weekend. So we were not available at that time, and even Google didn't alert us about the suspicious activity. Okay, so this is the cloud bill that was costed us between June 11 and June 13th. So this is not this is just for one billing account. We had 4 or 5 billing accounts. Okay, so in just one day, and in just 3 or 4 hours, we were costed this much. I will tell you how, but let's look at next chart. So this is in INR, but we had, as I said, multiple accounts, so it was close to $1 million. Okay, so we analyzed that because on June 12th, Google just sent us an email that your account has been suspended because of suspicious crypto mining activities. Okay, so in short, Google took down our entire platform, so everything was freeze, and we were just 3 or 4 members in the team at that time. I was an intern there, and later I was a tech lead, but at that time I was an intern, and we went into billing and we saw that App Engine costed us this much in just one day. Okay, so then we looked into the logs and we found out that the main culprit was service account. Okay, and if you've worked with App Engine, you know that the App Engine is not that restrictive. Okay, you can do anything in that. So as I told you, in our architecture, service accounts were not disabled by default. Even user could create keys, user could create service accounts, user could do anything with the service accounts. So in the logs, we found out that service accounts were the main issue. So what they did was they created a service account. So actually, before even logging, we created a service account for every user for that particular instance. So what they did was we mistakenly gave them the editing permissions for IAM permissions, and they edited the IAM the service account. They downloaded the key, and then they did everything for this crypto mining attack. Okay, and second thing was but the main issue was service accounts. The second thing was loose arm permissions. So as I told that we were not that restrictive about permissions because we never thought that this would happen. And third thing was as we were not informed about the bill, we missed an edge case. I think that you should also apply after this sessions. So there is an edge case in cloud billing and cloud budget alerting that we missed. And fourth is again, it was no restriction. It was just an open playground, just come and play. Okay, we won't do anything to you. So we were not having our internal policy checks or anything else. And next thing was poor cleanup. Okay, because by default our projects were assigned for 3 hours, right? But they found out a loophole that they utilized the particular same project for 5 hours. Okay, so we were not even, like, odds were against us. Okay, we were not able to get the billing data. Google was not informing us. We were having no restrictions on our platform. And this all happened over the weekend. Okay, so first thing is, this was how our billing alerts look like. So billing alerts are nothing. They will just alert you on actual or forecasted bill, depending on your usage. Okay, so this is amount one, and similarly we did that. So what happened was, on the weekend, uh, as we were reaching the 98%, though we as soon as the attack happened, in 1 or 2 minutes it reached 100%. Okay, and me and my uh, team lead at that time thought that it's okay, because at that moment we were having very huge spike in our traffic, and we thought that it's totally okay. So we will look into this issue on Monday. Okay, but the edge case here is, after 100% of budget alert, like budget percentage, Google won't even send you a single text that your bill has reached 150% or 200% or 300%. So this was the first loophole, because after 100% nobody is going to tell you. Okay, and uh, this is a thing that cloud vendors should even help out in creating a new feature. So what we did was, we created multiple, like, after the attack, we created multiple budget alerts. So we had a budget alert of 200%, 300%, 400%, 500%, because it may happen that overnight somebody is not available on email, or you just ignore one email, or one email is in spam. So we created multiple alerts for multiple higher limit percentages. Okay, for 150, 200, and 300. So I think you should also apply this thing in your architecture. Now, first thing was, as uh, okay, so the attack happened in two phases. Okay, the first one was in May. Let me show you. So the attack happened was, yeah, so attack happened was in May. Okay, so first attack was in May, second was in June. So right now I'm talking about the first attack, our hot patch. Okay, so when we saw such issue, we just applied a hot patch. By hot patch I mean, we flushed the entire old projects. So there were around 250 at that time. So we flushed the entire projects. We asked Google for more projects. Okay, and they were very good in providing us, because Google generally don't provide you projects. Okay, and we flushed old and we created new with a new billing account. So we disabled the previous one and we created a new one. Next thing was, we tightened our IAM permission. So we manually checked every permission of every like user facing lab. The third thing was, yeah, we added edge case. As I told you that this is a common loophole. Okay, and I'm sure that 90% of the people don't even know about it. And the fourth issue was, we blocked the users. Okay, this was our hot patch, because we thought that, okay, this was the first time, and after, if we block these particular users, nothing will happen. Okay, and because at that time our platform was down, so we had to tell Google that we have resolved it, so can you please make it up. Okay, so it all happened over a week, I think 2-3 days, Monday, Tuesday, Wednesday. And then the attack happened again on June. Okay, so again, this was a massive attack. As you can see, it was, first one was close to 1.1 million. Second one was more than 2.2 million. Okay, so this issue was same. Users were with some random email IDs. They logged into our platform, then they downloaded service account keys. I don't know how. Okay, Still we don't know how they downloaded the keys, because we maybe previous keys were not flushed, or they had some access to our some of our VMs. From there they created chain of VMs with high GPU. So okay, so the machines were not simple machines like N1 standard 2 or uh, N1 C1. Okay, so it was high GPUs because Google provided us some GPUs. So it was the maxed out machine with 256 gigs of RAM, and 12 vCPUs, the biggest machine that you can ever imagine. Okay, now what we thought was, okay, let's take a step back and now implement the things in a very like long term fashion. Okay, so what we did was we came to know about quotas. Okay, quotas, if you can like it is just like this speedometer. Okay, just like in cars the speedometer is of 200, but we can only accelerate till 120. Okay, we can't go till 200 in most of the Indian cars I'm talking about. So quotas are just like those speed barriers. Okay, they will prevent you from overspeeding for your own benefit. It's not like that the car can't go till 200 kilometers per hour, but it's for your own good. Similarly, we have quotas in every cloud platform. I don't know about Azure and AWS, but for Google Cloud we have quotas. I don't know the naming convention for others. So they will prevent you from over usage. Okay, because Google also knows that in cloud anything can happen. Okay, so they have already provided quotas, and these are not constants. Okay, so these can change depending on your request or on Google's like internal algorithms. So if you want to increase the quotas, the evaluation criteria is automated. Okay, nobody knows when will the quota increase, what are the parameters they are looking into, maybe daily active users or number of projects or billing, but most probably it's related to the billing part. Okay, and the next thing is quotas are not equal to resource allocation. I will show you in a moment how quotas look like, but quotas are not equal to resource allocation. Quotas are just the higher limit, but they never guarantee you that you will be granted resources. Resource availability is a different thing. Applying quotas to those resource availability is a different thing. Okay, and they can be applied at regional and global level depending on the resources you're talking about. And there are two types of quotas. One is allocated and second is rate quotas. Allocated are for the one I will be talking about. Rate quotas are for APIs. Okay, if you know the API hit limit, or like if you hit the API with like consecutively, it will return you 4 to 9. Okay, so related to that. But right now we used allocated quotas. Now let me show you how quotas look like. Okay, so yeah, so as soon as you go to the Google, so basically this is a organizational node I created yesterday, so I'm not able to edit it, but here we go. So these are a lot of APIs, because in every cloud vendor there are APIs. Okay, behind the APIs services are working. So as soon as I go to computing in API, these all are the resources. Okay, so here you can see quotas and system limits. Okay, so quotas look like this. The current value is 5, and they will show you everything. Okay, so right now the max you can go is 5 and current usage is 1. Okay, if you hit 6, it will just return you quota exceeded. It will just return you a warning, nothing will happen. Okay, and similarly for all the resources we have multiple quotas. Okay, you can just see in compute engine API we have near about 13,000 quotas. Okay, and we had 25 plus services at that time, so the task was huge. Okay, and it took us near about 3 months to resolve this issue. And so similarly, if we go to BigQuery or other APIs, there are multiple quotas. Okay, quotas are nothing. For example, you are into you want to restrict the usage of A2. Okay, A2 machine type, or maybe you want to restrict the number of networks, then you can go into quotas and override it. Okay, Previously when we were working, this was not there. Okay, create usage alert, it was not there. Okay, so and similarly you have for multiple things, go into it, explore it. Okay, but it is not available for free tier accounts. You need to have an workspace email id to go for it. Similarly we have for n1 tpus and all that. Okay, so coming back to the topic, uh, now as we saw quotas, so next thing is what are metrics. Okay, so quotas are in the left section that I just showed you, that these are the things at a very broader level, but metric is different. Okay, metrics are for example, you in a compute engine it is a read request or it is number of networks. So similarly metrics are there. Okay, metrics are more granular level. For quota there are metrics, and you can apply things at metric scale to just because after what we will seeing in Terraform code, we apply all those restrictions to a metric level. Okay, now but I guess that most of you got what I was saying, but how in the world will Terraform help? Okay, just give me a chat, give me a thumbs up or any idea in uh, on any idea how Terraform will help, or not just Terraform, any IIC or Pulumi or anything else will help. Okay, so meanwhile I know there is a delay in the uh, session, but let me tell you. So this is an action. Obviously I can't show you the entire code, but this is in the action. These were small scripts. I will show you my code as well, how we were playing around with all those metrics. As I showed you that we had 13,000 quotas in just Google Compute Engine API. We had BigQuery, Bigtable, Spanner, SQL, multiple services. So here you can see resources. Similarly it there is a this thing, Google underscore service underscore usage. This is an override. Okay, this is for not for Google, but it is for you. It is still in beta phase. Okay, from past 2 years it is in beta phase, and this is for the consumer to override the quotas. So for example, you want to restrict compute engine with n1 standard 1. Okay, you can't tell Google just make it 0. Okay, it is for you to make it 0. And as I told you, we had 400 plus projects, we had 25 plus services. So it was not viable to go into every project and do similar changes for every project. Okay, just restrict metrics for every project. It was just tedious. Even for one project it took us around 1 hour or 2 hour, or maybe just 3 hour, I don't remember, but it took a long, very long time. Okay, so this setting helps you to override some of the quotas and metrics. So provider here is Google beta. Okay, and project was war dot project, so we had a separate file war.tf, which will be picking the variable name as projects for 400, so it would continuously loop around. Okay, this was just a template. We will just loop around those project IDs and create. I will show you the code, don't worry. Okay, so the next thing was Google, cloudbuild.googleapis.com. As I told you that every service is behind an API. Okay, so similarly you can find for compute. Okay, compute.googleapis.com. And metric, as I told you, we will be applying the override values to a metric level. So these are some of the metrics, and you can do it in a workspace account, not in free trial account. Next thing was override value. The override value, some in some case it was true, some case it was false. So if you add -1 to override value, it will mean infinite. Okay, but we wanted certain values. For example, in create request we wanted just 5, so we made it 5. And force, if set to true, it means that if the change is more than 10%, okay, then it should be set to true. And like it is just a safety check. Okay, if you pass at force, then it will forcefully apply everything. Now the next thing was yeah so these were all the quotas. Let me show you how they look like. Okay, uh, Okay, so this was our directory hierarchy or anything that would say. So we had these were just the test, but as you can see, there are certain file with the name artifact null bq student bt. So what are these? So we had a shell script which would just because it was again not viable for us to create Terraform files for every service in every project. So it was not viable, so we created some shell scripts which would loop over the project IDs and create Terraform files. Okay, these are just these things, uh, the files, okay, with the boilerplate that we say. Okay, and next thing was uh, we created two files for each project. One was null, second was size up. Okay, so upsize or size up. So we created one file with the same name null and one for upsize. So null was that in case in future some attack happened, so we could just override the value to 0. Okay, and if not, then we could just set the limit, and the upsize meant that only. Okay, and the next thing was all files were getting created, and we ran again one shell script to apply or loop over for the Terraform to apply to all the projects. Okay, so this was how code looked like. So we created a boiler template, then we created scripts for each project. Each project had upsize and null in case of some future mishappening, and upsize in case of uh, like normal scenarios. Okay, so we would just apply one more shell script to apply these quotas to every project. Okay, now coming back to the slides. Yeah, so our new architecture looks like this. So if somebody uh, attacker came to us, so we had a layer TBL. Okay, even I don't remember the full form. Okay, just kidding, it is the Terraform blocking layer. So what we did was we added a bunch of shell scripts. So every time a user came in, it applied the quotas, or it just previously it was just applying quotas at every attempt, which was taking a lot of time. But then we started storing the state of projects, and just running a sample check for a random metric that would return us the thing. But again, it was a blocking layer. So if we saw that, and it was continuously monitoring that if the CP usage is greater than 5, 6 or 7. So if the usage was greater than 5 or 6, the user was automatically blocked at that time. If not, then you are good to go. Okay, and after applying Terraform at this level, at this layer, we found like there were just it was just a one incident, and that we also don't know how that particular user came into. But after that, nothing happened. And your question would be what happened to the bill. So the bill got reimbursed. Okay, because it was not our fault, it was not Google's fault, it was like it was shared responsibility. Okay, because security is shared responsibility. So the build was waived off, and we never paid a single penny. The conclusion and takeaway, please set up billing edge cases. Just look at your just do billing analysis, because I consult a lot of companies, and then they don't analyze the usage and cost. So just set up billing alerts. uh, Next thing was app engine issue was still not resolved, because API, the metrics that I showed you, Google has not still given APIs or metrics or quotas for app engine. So it's still not in beta, it is not in ideation phase till now, so we have disabled that. Automation can find its way, because here you can see IAC was not even applied for the resource provisioning. Okay, as we talk with the people, they have a perception that Terraform is for resource provisioning, but here it came as a tool for automation. Okay, and yeah, I don't know if Terraform was there. I think we could have applied manually. Okay, which would have taken again 4 to 5 months. And yeah, thank you. It's my email ID Prerit at qcloud.tech if you want something to discuss. And yeah, thank you.